Okay. Here we go. All right, permutation. So here's your blank to fill in. A permutation is an ordering of n objects. Permutation, ordering of n objects.
What is n stand for?
So just a number. So an ordering of 5 objects, 10 objects. So a number of objects. So I want to know how many permutations we could figure out of A, B, and C. So let's figure out maybe an organized list. So anyone want to start coming up with a way to organize these?
Wait, do you mean like groups of 3 or just 2?
Yeah, groups of 3.
I like to do the little chart thing with like A, B, C, A, B. I don't know, that just helps me think better.
Like the tree or a chart?
A chart. That's what I do.
So explain more, Tessa. So like A, B, C.
Like going across and then A, B, C down.
So A.
Maybe I'm thinking about it weird. I don't know how to describe it. I just know what I do.
A, B, C. How are you going to do it with? Can you do it with 3? Is that
I don't know. I just write out all the
I don't know that we can do it with 3. Dylan, I heard you next. How do you want to do it? We can. Lily, you just want to write it out?
Yeah, I just write it
So why don't I let you guys go about your own way? So I don't know that a chart like you, I don't know if you can do that with 3. But I would write it out. I'd do a tree diagram. I think both of those they're very similar. So I'll give you a chance to write that out, and then I'll get them up here, and we'll see if we can agree on the ways. So I come up with 6. Okay, so what do you have?
I did the tree thing.
Okay, so let's talk about problems with the tree. So how did you do the tree?
A, B, C.
So if I do A, B, C, I can't branch off and do A, B, C. Dylan, did you get the tree to work?
Yeah.
So how did you get it to work?
There was only 2 branches for each. So since you had A, B, B, and C, and B would be like A and C would be like A and B. And after that, you only had 1 more branch on each one.
We didn't say I only got to use the letter once.
So if I'm ordering think about it if you have 3 people. So like if it's the 3 of us right here. So if I want to order the 3 of us in a line, it's going to be me, you, and then Caitlin. And so the first one, I can pick any of us. So then the next person, I can only pick you or Caitlin. And so that's where I'm picking those letters from. Does that help with you, the understanding of it then? Okay. Are we okay? Okay from there? So are we okay with this part? So when I think about that, if I'm using the blanks, it's 3, then I have 2, and then I have 1. Right? If I go back to that fundamental counting principle, am I losing people? It's hard to read you guys today. So if I had 7 things that I wanted to order, so if I had 7 people in a class and I wanted to line them up at a door, what would I multiply? Like if I had 7 people in my preschool class and I wanted to line them up at the door, so I wanted to put them in line. And I want to know how many different ways could I line them up. So,
You start with 7 and then you.
so I'd have 7 people I could put first, then I'd have 6, then I'd have.
Oh, it's a factorial.
4.
So that was going to be my next question. So we can write that as 7 with an exclamation point. So Dylan knows that's called a factorial. Do the rest of us know that's called a factorial? So that's what's written next on that paper there. So a factorial, n with an exclamation point, means to multiply n times n minus 1 times n minus 2 times n minus 3. And so you may want to put an example next to that. You may want to put this example. So 7 factorial, I don't know if I have this on the next slide. So you may want to put 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And so the number of permutations for n distinct object is n factorial. So if I need the permutations, then I just use n factorials. This is, if I want to do zero factorial, if I said, hey, what's 0 factorial? What do you think it should be? Right? If I said, by looking at it, if I want to do 0 factorial, I didn't like how I wrote it down there. It seems like it should be 0 because you feel like it should be 0 times, well, nothing. Or go into the negative, but it seems like it just goes down to 1. Well, there isn't really a good reason why. It's by definition. I have a video, because we're short periods, we're not going to waste time on the video. I'll put it on Google Classroom if it really fascinates you. I know most of you probably won't look at it. But factorial itself is just something mathematicians made up. And so they defined this. They said factorial 0 is 1. I'm never going to give you this. We don't really need to know it, but it may be something that you just want to put on your paper just so you know. 0 factorial is 1, and that's just something that mathematicians define.
So it's kind of like if you have like 2 to 0 power.
I feel like this should be a key on here.
It's not even related to that because that's something we could back up mathematically. This isn't even something we could back up mathematically. It's just saying, I'm going to define this, and it is because I said so.
They should have a factorial button.
They do. So
Right.
that's our next thing. So on our calculators, I should have prepped a little better, but there is a button. I always got to look because I only use it once a year. I think we have to go to data. No. Probability. So hit 5 and then hit the PRB button and scroll over, and there is a exclamation point, and you should get 120.
Oh, that's cool.
So try another one. So do 8 PRB exclamation point,
2,000 times it.
40,320. Okay.
It says overflow error. No.
Yeah, if you get too big, it's not gonna record that number for you. All right, so let's try some examples. So 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. In how many different ways can the bobsledding teams finish the competition? Well, so you're looking for all 10 teams to finish. So what do you need to do? 10 factorial. So you're going to put 10 factorial in your calculator.
$3,628,800.
Yep. Whoops. $3,628,000. Lily said it so much better than I did. $3,628,800. The second part then is how many ways can 3 teams finish gold, silver, bronze? What do you think we're going to do for that? Kayla?
Would it just be 10 times 9 times 8?
Yeah. So now I'm starting to mix up whether we're going to use the factorial, whether we're going to do all the things, or whether we're going to need that blank method. Well, this I'm only talking about 3 situations, so I'm just going to do 10 times 9 times 8. What do I get?
720.
So 720, whereas this, since it was all of them, I'm going down to the one team standing alone, so that's why I use 10 factorial. And so as you get later on into this assignment tonight, we are starting to mix them up, and we're going to get to a couple other, or one other counting method today, which is a permutation, which is that other, do you see this thing when you go into that probability menu? So we're going to talk about that right now. So permutation of n objects, so number of objects taken r at a time. The number of r objects taken from a group of n distinct objects is denoted by n capital P R, and the formula is n capital P R is equal to n factorial over n minus r factorial. I'm not going to make you memorize this formula. We have that function on our calculator that does this. What is super important is for permutations, because we learn a different thing tomorrow called combinations, but for permutation, the order matters. So the order things happen matters. So like when we were doing that bobsledding, the order they come in first, second, third, fourth, and fifth, it matters. Or when people line up at the door, they line up first, second, third, that matters. Whereas if I just have a group of preschoolers, it doesn't matter. They're just all in a group. They're all in a cluster. That's going to be a different way I can have groups of students. So here's the next example on that page. You are making a playlist for your band. Your band has 12 songs. You only have to play 4 songs. How many ways can you arrange 4 of the 12 songs? We're assuming here, and I should have been more specific when I wrote this out, the order I play these songs matters. So it isn't just, oh, I want to play 4 of them. The way I play them matters. So if I were to play, I can't think of a song now off the top of my head. Give me a song name.
Day and night, like the cutting.
What?
Day and night.
Day and night. Give me another one.
Sober by AJ.
Silver. So if I play day and night and silver, that's different than playing. Are you saying silver?
Sober.
Sober. So if I say sober and day and night, that's different than day and night and then sober. So the order I play those in matters. So those are 2 different things. Do you understand what I'm saying?
Yeah.
So the way I play my song list is going to be different. I feel like I've lost you. I feel like I've lost Lily.
Just do one and then I'll understand.
Okay. So how many songs do I have? So like if I have, we don't have CDs now, but like if I were making my playlist on my phone or whatever.
But it's always going to go that way and you can't change it?
Yes. Okay.
That's shuffle.
So how many, but I'm not hitting shuffle.
Okay, well, I'm just saying not shuffling.
Why not?
So how many total songs does my band have?
12.
So I have 12 songs. I'm gonna pick.
You're in a band?
I am not, clearly.
Why not?
I am not musical. I am not artistic.
Are you and Mr. Schultz in the same band?
Nope. How many songs am I gonna pick? 4. So that's the way I set up my problem. So in my calculator, I type in the 12. I go into that menu. I pick the n. So I do 12. I go in. I pick that function, and then I go back. I hit 4, and I hit equal.
11,880.
Yes.
Why do you have to go back out into the 4?
That's just the way the calculator works.
That just doesn't, it doesn't make sense, 'cause like looking at it, it's weird.
It's just that's how it divides up where the NN is and where the R is.
Like I get it. I
Yeah.
just, it looks weird.
Different calculators do it different ways. All right. So now the next one is how many different ways can 4 raffle tickets be selected from 50 tickets if each wins a different prize? So it's not like everyone's winning $25. First place is going to win 1,000. Second place is going to win 500. Third is going to win 50, and fourth is going to win $10. Well, right. So you definitely want to be first place. So it's going to matter if your ticket's picked first or if your ticket's picked fourth. So how many tickets are there? So you're going to pick how many?
4.
So you're going to set that up. This is what you're going to show me as your work. You're going to put that in your calculator.
5,527,200.
Man, you think there aren't a lot of combinations out of just 50 raffle tickets, but there are.
That makes me not want to do it.
You think like you're just over here at the Madison basketball game, they're doing split the pot, and wow, that's a lot of possibilities there.
We don't have to worry about it, you just do it. Well,
It's going to a good cause. That's what I always tell myself. I do it every time I go to the Reds game. Just a sucker.
You ever won?
Nope.
That's tough.
I know. Still do it. Yeah.
So is this just a replacement for like 50 times 49 times 48 times 47?
Yes. Yep. So I think we know how to plug it into our calculators, right? So I don't feel like we have to do that. That's what just evaluate. You'll have some of those. Then permutations with repetition. Gosh, if I can talk today. N factorial over S subscript 1 factorial, S subscript 2 factorial, S subscript 3. Those are all the repeated objects.
Is that what we have to put in the?
That's what you're put. I did not give you very much room. I apologize. You might want to put it that blank. You might want to put it off to the side where there's a little more room.
Is the S like is it S1 explanation point?
Let me see if I can write it better. So N factorial over S subscript 1 factorial times S subscript 2 factorial dot S subscript K factorial. Is that a little neater?
What does the Q stand for? Just any number?
So however many repeats there are.
So would you put in like the number of repeats for K?
Yep. So K is the number of repeats.
And then the dots, is it just multiplication? Or?
Yes. And so it's saying you multiply however many repeats there are.
Oh,
You keep
okay.
multiplying
Got it.
until there's no more repeats. Okay, so then let me put Miami right here. All right, so we want to find the number of distinguishable permutations. So this is when we have repetition. We want to get rid of those repetition. So there are 5 letters, so that would be our N. So 5 is our N, because there's a total of 5 letters. And then we want to see what's repeated. Well, what's repeated? So M is repeated twice. So that would be one of the S's. So 2 factorial. I is repeated twice. So that would be another 2 factorial.
And then since the A is just 1,
We don't need it. We only need the repeated ones down here. So that's what I'm going to plug it now. You can do it in parts. You can do it all together. If you do it all together, you got to put this whole thing in parentheses.
Oh, 30.
30? Yeah. I thought you said 130 at first. You should get 30.
I did not.
Did you put the bottom in parentheses?
Okay.
Is anyone not getting 30?
So I get it when we like do the example, but
Okay.
for the formula, it just, the bottom doesn't really make sense to me.
So however many, whatever's repeated is gonna go down here.
Okay.
And the S is however many times that thing is repeated.
I feel like it's
Okay,
been
so what
R
is
now.
like the 1, 2,
You could put it as an R if you wanted.
what is like the 1 and the 2?
It's saying, okay, one thing's repeated, two things repeated.
Oh, so it's how many different things?
Yes.
Okay, I got it.
So why don't you guys try and do Tallahassee? Fun word.
Do you want us just to say?
No, I was just letting people.
That looks like a lot.
Yeah,
I
don't
got-
know if I'm right.
831,600.
Oh, okay, cool. Okay.
It's not, you're gonna find they go pretty quick, I think. It's, so your homework then is that same page, 19 through 43 odd, and then 48 and 63. And we only have a couple minutes left. And then tomorrow we'll have another, we'll have another study guide. We'll talk about what are called combinations, and so we'll have, by the time we're done here, we'll have the fundamental counting principle, that blank method, permutations, combinations. Those are our three basic ways to count, and so we'll have to distinguish when to use what method. That will be the big thing we'll talk about.